Hey folks, this is Nate the Botanist, and I'm here today to show off yet another beautiful bloom. We're going to be taking a look at Dinteranthus wilmottianus today, a weird little golf ball of a plant. Dinteranthus is another succulent out of the Orange River Valley that forms the border between South Africa and Namibia. Like most of these guys, these are extremely endemic, being found in 10 to 20 known locations on quartz shale on the southern side of the Orange River. Dinteranthus is a small group of plants with 7 described species that fit neatly into Azoaceae somewhere near Lapidaria and Lithops. They're summer growers and fall bloomers, theoretically. Like all my plants, they're a bit confused, but I think that's because I'm growing inside with not enough temperature variation. When I got this plant, it was only a couple centimeters across. It came with basically no roots, so it was just a tiny gray sphere. I was so excited to get it growing that I popped it in the only pot I had at the time, this big yellow glazed one. For the first few months, I think I underwatered it. The very, very little literature of cultivation comes once again from Stephen Hammer and his invaluable The New Art of Mastering Growing Mesoms, and it drives home the point that Dinteranthus is very sensitive to water, even more so than most other Azoaceae. Once I started occasionally misting it, it sprung to life. It quickly split, doubling or tripling in size in the process. What I thought was just another split recently turned out to be much more. I wasn't expecting this. A huge, beautiful flower that perfectly matches the pot. This is a stunning flower and a little different than the other ones I've been showing off. First, let's look at the things we've seen before. Tons of anthers where pollen is produced, brightly colored, what do you call these? I should know, I'm a botanist. Petals? No, these are petaloid staminodes. Sterile stamen modified to look exactly like flower petals, while the actual corolla is completely absent. This very weird fact is true across Azoaceae. Very strange that a flowering plant would reduce its petals to nothing while developing new features barely distinguishable from petals. But hey, that's evolution for you. Research on flower parts is still ongoing, and the place staminodes fall in flower evolution is up for debate. Now some of the different features. Look at the length of the pistil here. The stigma are really hanging in the breeze. This might be pollinator preference or another mechanism of preventing self-pollination by physically separating the male and female bits. In my video on Fenestraria, I mentioned using the pollen to self-fertilize self-sterile plants, but that's not a trick we need here. Dinteranthus is self-fertile, with some help, and I'm going to be mashing a clean brush around in this flower over the next few days it's open to try to get some seed. For that process, I may end up having to collect some pollen, which is fine, because Dinteranthus also crossed with the other Azoaceae. They're known to cross with Lithops into the weird Dinterops group, which would be a fun experiment. Unfortunately, I don't have stored Lithops pollen. I will try to save some of this pollen to cross with the Lithops later, though. This has been a super fun plant to watch grow, and I'm amazed to get a flower like this after just 1 year. The matching pot was a stroke of luck, and I'm very happy with how this all came out. More videos to come with more beautiful flowers and facts for you. Happy horticulture!